Hi everyone, this example is going to look at a fairly simple velocity function, but it's going to get into this whole positive negative velocity thing and a distinction that we need to be really careful about with that. So we have the graph that shows an object's velocity. We know this object is moving along the x-axis. It starts at the origin. So here, imagine a separate x-axis. This is where the object actually is. And here's the origin, and it starts at the origin and it heads to the right when velocity is positive and it heads to the left when velocity is negative. Okay, so first question is actually a Calc 1 question. If we're looking at a velocity function and we're interested in acceleration, we're talking about derivative of velocity, which is slope, and this is a pretty nice velocity function. Being just linear, so we should be able to count out that slope. So I see a rise of -2 and a run of 1, which means its acceleration is -2 centimeters per second squared. So the velocity is decreasing by 2 centimeters per second every 1 second. The next question is, when does the object change direction? So you can see we have positive velocity and it's slowing down, and then right here it stops, and the negative velocity means it's changed directions. So at t equals 3 seconds, it changes direction. Okay, now we get into the distinction that I want you to really pay attention to. I want to think about how far this thing has actually moved, so how far it will travel. And I want to think about where it's actually sitting on the x-axis. What is its x-coordinate? During the first second. Oh, I almost missed that I had a first question there. Okay, so during the first second, here's t equals 1. We're interested in how far it's traveled, and hopefully you're making the connection that that's going to be an area question when we're looking at this velocity curve. So notice that each one of these squares is 1 by 2, so this is 2 centimeters, right? So 1 second multiplied by 2 centimeters per second. And then the same thing with this one is another 2 centimeters, and this is half, so this is 1 centimeter. So during the first second, it's traveled 5 centimeters. It's headed to the right, so we're out here, we'll say right about here, at 5 centimeters when t equals 1. So right now, not a very interesting difference between those two questions, but there will be. Okay, now if we go out to 2 seconds, we're going to add another 2 centimeters and another centimeter. So 5 and 3, we're at 8 centimeters traveled. It's all to the right. So once again, this isn't a terribly interesting question, the second one. It's traveled 8 centimeters to the right from the origin, so it's at x equals 8. At 3 seconds, when we actually come to a stop, we've added 1 more centimeter. So it's now traveled a total of 9 centimeters and is sitting at x equals 9. Okay, here's where it starts to get a little bit more interesting. Now we are traveling to the left. So if our velocity is -2 centimeters per second, and our distance is 1, and then we have to cut that in half, this has an area of 1. But that means we've traveled 1 to the left. So now we've traveled 9 centimeters total up here and 1 centimeter back where we started. So that's a grand total of 10 centimeters. So total distance traveled is 10 centimeters, but our x-coordinate is not 10 because we've actually backed up. So we went way out to 9, and then we went back 1, and we're now sitting at x equals 8 again. Okay, so this is important. I guess I should put some words on it. So we have a total distance traveled over here, total distance. And then here, what this is really called is displacement. So displacement is final position minus initial position. It's how far you are from where you started. something like that. Okay, so if we continue this at 5 seconds, we now have another 2 and 1, so we've traveled 2, 3, 4 to the left, which means we are at another 4, so 14 centimeters. See if I can keep straight which question comes first. Okay, so we went 9 to the right, and we've now gone, 13. 4 to the left, and that's a grand total of 13 centimeters, and that puts us at x equals 5. So we went 9 centimeters out, we came 4 centimeters back, we're at x equals 5. That's our displacement. And then last one, 6 seconds. So now we have the 1, okay, let's see, 2, 3, 4, 5, 6, 7, 8, 9, which I guess we could have gotten from symmetry as well. So this is now 9 centimeters right and 9 centimeters left, which means we've gone a grand total of 18 centimeters, and we are back to x equals 0. So negative velocity, I hope, seems pretty easy to make sense of. Negative area isn't really a thing, but when we do the area problem, we'll have to think about this as well. So this is just kind of precursor to that. When we have the curve dropping below the x-axis, that doesn't mean we've lost all of our area meaning. It just means something particular we'll have to be careful with. All right, thanks for watching.